let us try to understand what is vCenter inventory. Okay. So here guys, vCenter inventory is nothing but hierarchy of objects. Objects are nothing but the components what we manage, like host, virtual machines, so on and so forth. What is vCenter inventory? vCenter inventory is nothing but hierarchy of objects. The first thing what we can do is that we have to create a data center. What is the meaning of data center? Just have a look here, guys. A data center contains all inventory objects such as hosts and virtual machines, and you might need only one data center in your organization, but your organization may use multiple data centers to represent organizational units. So here data center is similar to an organizational unit. It's a logical container where you can group certain hosts which belong to certain departments, like there might be multiple departments in your infrastructure, or multiple applications. So in this way, you can group them in a logical manner, and you can manage them by assigning permissions, so on and so forth. So here, if you see this slide, I have created 4 different data centers. Okay, these are nothing but logical containers where you can group hosts and manage those hosts and virtual machines from there. I have created data centers with the name Hyderabad Data Center, Bangalore, Chennai, and Pune. Now, it doesn't mean that I'm managing the data centers which are physically located at 4 different cities from this vCenter server. No, it is not like that. As I told you, data center here means nothing but a logical container where you can group certain hosts, and I can manage it by assigning certain permissions on it. So if you see this here, hierarchy of objects, vCenter inventory is nothing but hierarchy of objects. The objects can be folders like this, okay, like a data center, or objects can be the objects that we manage, like host and virtual machine. Now, why are we grouping them in a meaningful way? Now, we are grouping them in a meaningful way so that we can manage them by assigning certain permissions, and so that permissions can be applied, so on and so forth. Now, let me give an example of this. Now, let us say in my infrastructure there are 400 hosts running ESXi. On top of it, there are virtual machines. And let us say that my company is having operations in Chennai, Bangalore, Pune, and Hyderabad. However, all the IT infrastructure is available only at Hyderabad. We have a physical data center in Hyderabad where the entire IT infrastructure is located. And there are administrators and users in Hyderabad, Bangalore, Chennai, and Pune. They get connected to my data center. And let us assume that there are 100 hosts which are running the virtual machines and applications related to Hyderabad operations, 100 hosts running virtual machines and hosts related to Bangalore operations, 100 hosts which are running virtual machines and applications related to Chennai, and 100 hosts running virtual machines and applications related to Pune operations. Now, there will be different teams managing these Hyderabad servers and Bangalore and Chennai and Pune servers. So, how can I group them? So, that's the reason why I create these logical containers like organization units called as data centers. I will name them with the name of the operations like Hyderabad, Bangalore, Chennai, and Pune. It doesn't mean that they are physically located in 4 different cities. Okay. The naming of these data centers can also be based on, like, there might be certain hosts which are running production virtual machines or production hosts. So I can name it as production, the data center name as production. And there might be certain hosts which are used for development and test. So I can create a data center with the name development, test, and test, and I can move certain hosts into it. So that is the meaning of objects, and vCenter inventory is nothing but hierarchy of objects. So now let us see how to create a data center. Just right click on your vCenter server and you find the option which says new data center, and here I can name it in this way, maybe production at Hyderabad. That means it's a production servers, production ESXi hosts of Hyderabad operations can be added here. Okay, and or can simply be in this way, like development and test data center. I can add the hosts which are used for development and test here. So it can be any meaningful name so that I can logically group them. Alright. And guys, when you are using your vCenter servers, I told you not everyone requires vCenter server. You can create only one vCenter server and all you 5 and 6 people can use the same vCenter. Fine. And suppose if you are using your vCenter server, then whether you create a data center with this name, maybe you can give it a name like production, or you can just directly give your name. So for example, Prabhakar. So Prabhakar's data center, and you can add your virtual ESXi's that you have created. You have created 2 virtual ESXi's, right? So you can add those 2 virtual ESXi's to this data center. So I have created a data center. Now the next step involves is to add a host. So let me add the host of Prabhakar. Prabhakar has 2 ESXi hosts, so let me add that. Right click, add a host, and the IP. Prabhakar, what is the IP we are using? I think it's 10.83.0.20. Am I right? Let me check out.
It's 40.
One is 20 and other is 40?
Yeah.
Okay, fine. Yes, it is 20 and 40. Fine. So let us add Prabhakar's ESXi host to this data center now. The username group. The password is the same, uppercase SOOM1234?
Same password.
Okay, fine. So click on next. Yes. Next. Guys, this is the place where you can assign a license key to your ESXi host. Okay. Suppose you have purchased the license, you can enter the license key here, and that would be a 25-character key, and you have to enter the license key. And guys, vCenter server is also your licensing server. So vCenter server keeps a track of all the licenses on every ESXi host here in infrastructure. Click on next. Guys, we discussed about lockdown mode, right? So when you enable this lockdown mode, then no one will be able to connect to the host which I'm adding right now directly. If I want to manage this host, then I have to manage only through vCenter server. Once you enable this lockdown mode, direct connections are not possible. Only connections the way you can manage this host would be only through vCenter. Okay. So this is how you enable lockdown mode. However, I'm not enabling it. Here, this is the entire summary. Finish. You need to see in the progress right now, in the recent task in progress. Okay. You can see something in the details. It is retrieving data from vCenter agent. Why? Because the communication from vCenter server to ESXi host, from ESXi host to vCenter server occurs with the agent, which is the vCenter agent, which is running as a process on ESXi host. That is VPXA. The process name is VPXA. So it is retaining the information from vCenter agent. Slowly, this host gets added to your vCenter server. In the same way, let us add the other ESXi host. Add host. And the other IP is 10.83.0.40. Root. Again, the same way. I'm not enabling lockdown mode. Again, it will retrieve the information from the agent, and that host gets added to this. Now, this is vCenter server. Now, there is no need for me to create 2 different sessions to manage 0.20 and 0.40 ESXi host. Now, once I am connected to my vCenter server, I can manage 0.20 as well as 0.40. Fine. So this is how we manage multiple ESXi hosts in your infrastructure. vCenter has a capacity of managing 1000 ESXi hosts. Fine. However, guys, when you access the ESXi host directly using vSphere client, For example, I'm accessing 10.83.0.20. I'm entering the credentials of root. Okay. But when I'm accessing vCenter server, I'm entering the credentials of the Windows Domain Administrator credentials. Right. But right now, if I click on 10.83.0.20 on my vCenter server, that means I'm connected to my vCenter server through vCenter, connected to my ESXi host through vCenter. Now, how does ESXi host is able to access that particular host? What account it is using?
Hi,
yes.
Sorry, Usman. I actually missed your initial 10 minutes. Can you just really brief me what exactly you're trying to do here? Sorry about that.
Okay. Guys, yesterday we have seen the installation of ESXi, right? vCenter server. Okay. Now, we get connected to vCenter server. The first thing what you have to do is to add an ESXi host to your vCenter. So you cannot add an ESXi host to vCenter directly. First, you have to create inventory in vCenter server. Okay. Inventory is nothing but hierarchy of objects, basically. Okay. First, you'll be able to create a data center. Guys, data center is nothing but a logical container where you can group certain hosts and virtual machines and manage them in a meaningful manner, and you can also assign permissions. It is similar to organizational unit as we have organizational unit in Active Directory infrastructure. The same way here, a data center is a logical container where you can add hosts and virtual machines and manage them, and I can create a hierarchy of objects in a meaningful manner so that I can assign permissions. So here right now I have created different data centers. For example, here I have named the data center as production at Hyderabad. So what is the meaning of it is that I can add certain hosts into it, which are production ESXi hosts, and they manage certain operations of Hyderabad. I can also create data centers by the name like development and test, where I can add the hosts which are used for development and test in my infrastructure. Okay. And while practicing, guys, you can create data centers with your own name so that you can add ESXi hosts to it. So the first thing, create data centers, then add host to it by clicking on add, and you can enter the IP address of the ESXi host, username and password, and continue. So once you add an ESXi,
how do you create the data center?
It's pretty simple. Right click on the vCenter, which is on the top. Right click, new data center. That's it. Okay. Give a name to it.
Fair enough.
Here, data center is nothing but a logical container where you can group certain hosts and virtual machines, which may be running certain virtual machines and applications related to a particular department or certain operations, so on and so forth. Here, this is what is called as vCenter inventory, hierarchy of objects, and data centers are nothing but logical containers for managing hosts and virtual machines in a meaningful way. That's it. Okay. Right. Now, once we add an ESXi host to vCenter server, I will be able to manage multiple ESXi hosts from the single session getting connected to vCenter. Now, guys, you need to understand this, that when you are accessing an ESXi host directly, you use the credentials of the ESXi host, for example, root. But when you get connected to your vCenter server, we use the credentials of Windows machines. Why? Because here vCenter server application is running on a Windows machine. However, through vCenter server, I'm accessing an ESXi host. When I click on this host, 10.83.0.20, that means vCenter server is accessing this host. But with which account vCenter server is accessing this host? Let us try to understand that. There is a separate account, guys, on an ESXi host. You'll be able to see that. See, this is my 10.83.0.20, and I'm connected directly to it. You have this tab called local users and groups. When I go here, you find three users. The first one is root. We know whenever we get connected to this ESXi host directly, we have to use root account. Okay. And then here you find DCUI, That is nothing but direct console user interface by which we configure our ESXi host initially, assigning an IP address, DNS, and default gateway. And here in between, you find another user with the name VPX user. Now, this is the account which vCenter server used to access this ESXi host. This is the account, guys. If you see the description of it, VMware Virtual Center Administration account. So that means your vCenter server is accessing this ESXi host through this account, VPX user. So this is the username, and there is a password in the background, which is mutually understandable between ESXi host and vCenter server, and that password is 32-character password, and this password is regenerated every 30 days, or this is renewed every 30 days. So wherever I'm getting connected to my vCenter server and I'm accessing an ESXi host, so in the background, my vCenter server is using the account VPX user. On every ESXi host, you find this user called VPX user. And vCenter server is accessing that host by using that particular account, which is VPX user. And in the background, there is also a password, which is mutually understandable between ESXi host and vCenter server system. And here, the password is 32-character password, and it gets regenerated every 30 days. Right? So this is the mechanism behind how vCenter server accesses an ESXi host by using an account. Right, guys, this is how we can add multiple ESXi hosts and manage them from a centralized location. And we also know that vCenter is very, very important for vSphere operations, because if we want to use all the advanced features like vMotion, storage vMotion, clustering concepts like HA, DRS, FT, all these operations are possible only through vCenter server. If there is no vCenter server, then you cannot perform the advanced features, like you cannot perform vMotion, SVMotion, and clustering concepts, so on and so forth. So very important in our vSphere infrastructure. It's a centralized management server, provides central point of administration of your entire vSphere infrastructure. Yeah?
Sorry, Mujib, did you say it uses the root account, right?
Pardon?
The vCenter server that you host, when you ask connected, it uses the root account. Is that what you said?
See, guys, when you access an ESXi host directly, I use the root account, right?
Yeah.
Now, but when I'm accessing my ESXi host through vCenter server is accessing this ESXi host, right?
Yeah.
So here, when ESXi host is accessing this ESXi host, it is using a different account. It is not using root account, but it is using a different account. You can see this account here, this account, VPX user.
Okay.
This is the account by which your vCenter server is accessing this ESXi host. I am able to access here. You find this 10.83.0.20. This is on my vCenter server, right?
Yeah.
So that means I'm accessing this ESXi host through vCenter. But in the background, my vCenter server is accessing this host with which account? With this account. It is not accessing the ESXi host with root account, but it is accessing by its own account called VPX user. It is the account which is available on every ESXi host. It is vCenter administration account. And this is the username. And in the background, there is a password of 32 characters. And this is generated every 30 days. And it is mutually understandable between the ESXi host and vCenter here. So this is the process which happens in the background. So whenever you are accessing an ESXi host through vCenter server, then that means that your vCenter server is accessing that host through this account, VPX user account. Yeah?
Yes.
Alright. So this is how we manage multiple ESXi hosts, and we add multiple ESXi hosts to our infrastructure, and we'll be able to manage that from a single location, from a central point of administration. Alright? So let us move forward from here. Let us start the new topic today with this story.
So I have one doubt.
Yeah.
Yeah, actually that ESXi host can be a member of one vCenter server, or it can be any number of vCenter servers, multiple.
It can be a member of only one vCenter server at a time.
Oh, okay.
Okay. It can be a member of only one vCenter server at a time. It cannot be a member of multiple vCenter servers at a time.
Okay, thank you. Yeah.
Welcome. Right. So we'll move on to our next topic, which is very, very important and critical for VMware administrators, which is storage. Centralized storage, okay? So let us see that. Okay guys, shared storage, fine, very important. Guys, normally storage is basically classified into three types. The first one is DAS, second one is SAN, the third one is NAS. DAS stands for Direct Attached Storage, and then comes the shared storage. Under the shared, you find two types of storage technologies. One is SAN technology and the other one is NAS technology. What is direct attached storage? Any storage device which is directly connected to your system with no networking device in between. So that comes under direct attached storage. So the hard disk which is directly connected to your server, that is direct attached storage. Any device, any storage device which is directly connected to your system with no networking in between, that comes under direct attached storage. Okay. Then comes the shared storage or centralized storage. In shared storage, the storage device is connected to your system through networking. So that means the storage device in shared is in a network. That means it is not directly connected to your system. So that means the device is on some other location, not directly connected, maybe on some other system, and you are accessing that storage device using networking. Okay, some sort of device or a cable is used in between. A networking cable will be used in between. All right. So that's the basic difference between direct attached storage and shared storage or the centralized storage. So under shared storage, there are two types of storage technologies. The SAN stands for Storage Area Network, and the next one is NAS, Network Attached Storage. First, we'll try to understand what is SAN. Okay, Storage Area Network. Guys, SAN is nothing but a machine or a box, SAN system. Now, SAN storage system, this system or this machine or this box will contain multiple hard disks. It contains multiple hard disks, guys. Like in this way, there are multiple hard disks. And in the background, there might be RAIDs configured. You understand RAID, guys? RAID 6. So this can be hardware level RAID or software. Okay, in the background you have RAIDs configured, and using those RAID we can create a RAID set. Okay, now using those RAID sets, I will create logical units. In SAN technology, we call them as LUN, like logical unit number. Fine. Now, what happens in SAN is that there might be multiple systems in your infrastructure. which are connected to your SAN, maybe directly or through a networking device in between, maybe a switch. Okay, they are connected in this way to a switch. Through the switch, it is connected to our SAN. Now, on SAN storage system, we have multiple hard disks. In the background, we may have certain RAID controllers, hardware level RAID controllers, or we can also create RAID sets by using certain software. And out of those RAID sets, we'll create LUNs, or nothing but logical units. I can consider, or in order to understand what is the logical unit, you can call it as a logical hard disk. Okay, just for our understanding. Now, guys, what do you find on a hard disk? What is there on hard disk, or how is hard disk divided? It is divided into sectors and blocks. Am I right? Okay, so we can consider the hard disk as blocks. Okay. Now, what SAN does basically is that it will present these blocks as local blocks to your systems. What is SAN doing? It is presenting the blocks on the SAN storage, that means these LUNs, okay, as local blocks to your systems in your network. Now, when your system is accessing this LUN, okay, this LUN is presented as local block to your system, and your system will consider it as a local hard disk. What it will consider? It will consider it as a local hard disk. Now, as it is considered as a local hard disk, can I format that hard disk, guys? Any hard disk which is connected to my machine, can I format it? Yes or no?
Yes.
Yes. Now, I'm going to format that hard disk. Now, with which file system I'm going to format it? With which file system I'm going to format it?
According to OS.
Absolutely right, based on the OS. Now, let us assume that here I have 3 machines in my infrastructure. Let us assume the first machine is running Windows. Second machine is running Linux. The third machine here is running my ESXi. Okay. Now let us assume the first LUN, the first logical hard disk is being accessed by Windows. So here Windows is going to format this with NDFS. Let us say the second LUN is being accessed by the Linux machine. So Linux is going to format this with ext3 or ext4, whatever it is. Okay. Now the third logical hard disk, which is a LUN which is being accessed by ESXi, let us assume. Now it will format that with VM7. So here what SAN is doing, it is presenting the blocks as local blocks to your operating systems, to your systems in your network. Okay, and your operating systems, when they're accessing these LUNs, these logical hard disks, they'll consider them as local hard disks. Okay, now SAN uses different protocols. Protocol like FC, that means fiber channel protocol, and again in FC you have another protocol like FC OE, which is called as fiber channel over Ethernet, and it can also have another protocol like ISC, which is another protocol used on SAN, Internet SCSI. Now these are the different protocols used in our SAN network in order to access these LUNs from our systems. And here SAN presents blocks as local blocks to your machines. Fine. And whatever the operating system is running on that machine, it is going to format that LUN with that respective file system, and we can use that LUN as a local hard disk, and we can install the application and run applications on it. Alright. Now here SAN is considered as a shared storage because these LUNs or these hard disks can be shared by multiple systems in your network. Multiple systems in your network. That's the reason why it is called as shared storage, because the storage can be shared by multiple systems in your network, and multiple systems can access this storage. So this is basically SAN. Now when it comes to NAS, guys, NAS is also a NAS system, NAS box. Okay, it may also contain multiple hard disk drives. For redundancy, maybe you can also have in the background RAID configured. However, in NAS, we are not presenting blocks as local blocks to the system. We are not sharing the blocks here. However, we are sharing folders. What are we sharing here? Folders, guys. We are not sharing the blocks. We are sharing folders. Okay. Now, guys, can you format a folder? Can you format a folder, guys? Guys, are you able to understand? Can you format a folder?
No, we cannot.
You cannot. So can you store a folder on a raw block?
No.
No, that means on NAS, the hard disks are already formatted with some sort of file system, okay, in the background. Now, what type of file system which is used to format this hard disk on my NAS box? It depends on the operating system running on that NAS box. That NAS box may be running Linux or Unix. It may be running Windows or some other operating system. It may be developed by your storage vendor. Alright. So these hard disks on NAS box are already formatted with some sort of file system, and we create folders on it, and we export these folders as local folders to the systems in our network. So we are sharing these folders, basically. We are exporting these folders as local folders to your systems in your network. Okay. Now, in order to export these folders as local folders in our network, we use different protocols on NAS. What are the protocols which are used in NAS? Most widely used protocols: NFS, CIFS, and SMB. Okay, these are the most widely used protocols in order to export these folders on NAS boxes as local folders to your systems in your network. Okay, now here, however, let me talk about ESXi. Now, ESXi can access only those folders on NAS which has been exported using NFS protocol. So, ESXi supports only NFS protocol on NAS. Clear? Now, on my NAS box, I have created a folder and I want to share this folder so that the systems in my network can use it as local folders to store certain data. And while I'm exporting this folder, I have to use a protocol. Okay. Now, suppose this is the first folder I have created and I want to export this folder so that it can be shared across my network so that multiple systems in my network can store data on it. When I'm exporting, I have to export it using certain protocol. Suppose I'm exporting this folder using NFS, then ESXi can access this particular folder. Suppose there is another folder I have created and I want to export this using CIFS protocol, then ESXi cannot access that. Why? Because ESXi doesn't support CIFS or SMB. It supports only NFS protocol on NAS. Yeah. So, what is the basic difference between SAN and NAS? In SAN, blocks are being shared and being presented as local blocks to your systems in your network. Okay. Whereas in NAS, folders are being shared. Blocks are being shared in NAS and SAN, you can format those blocks and you can format those blocks with the respective file systems running on those systems, and you can install certain applications, so on and so forth. Whereas on NAS, as we are exporting folders, that means the hard disk on NAS boxes are already formatted with some sort of file system, and we create folders on it, or maybe a partition. I can entirely export that partition as a shared folder to the systems in my network. In order to export those folders, I'm using certain protocols on NAS like NFS, CIFS, and SMB. On SAN, in order to export these blocks as local blocks to your system, we use certain protocols like Fiber Channel, FCOE, and iSCSI. Okay. Now, what are the protocols and how these protocols are we are going to use, guys? It depends on the connectivity. If the medium is fiber channel, then it would be an FC SAN and the protocol would be used FC. And if the medium is, a normal Ethernet, and if the protocol is iSCSI, then it would be iSCSI protocol. And if the protocol is FCOE, fiber channel over Ethernet, then we are going to use FCOE protocol. So we'll try to understand these protocols in detail now. Okay. So guys, we'll try to understand another important point. Now, whenever ESXi is communicating with its SAN devices, those LUNs, okay, it always issues SCSI commands. It always issues SCSI commands. Whenever it is communicating with the LUNs, it is issuing SCSI commands. Okay, keep that in mind. And what happens? What is the medium in between? Fiber channel. So in the fiber channel, you don't have other protocols like TCP/IP. In fiber channel, we have fiber channel protocol. Okay, so let us try to understand different protocols and different storage technologies here. Guys, in the beginning, I have explained you data store is a generic term. Data store is nothing but a logical container where you can store data, and data store is nothing but a logical container that holds files. Now, in ESXi, there are two types of storage, two types of data stores. Sorry, the first one is VMFS data store. That means data stores formatted with VMFS. That is called as VMFS data store. That can be a local hard disk or a shared hard disk on your SAN. Now, NFS data store. In NFS, the data store is already formatted with the file system on NFS, and a folder is being shared, and it is being shared from the storage provider. That is NFS data store. Now, let us talk about these different technologies. DAS, we already discussed this. Any storage devices is directly connected to your system with no networking device in between. That is called as direct attached storage. And in SAN, I told you different protocols are used. FC, a fiber channel. This is a protocol used for SANs. And just now I told you that ESXi always issues SCSI commands, and these SCSI commands has to be transmitted to your SAN system, to your SAN storage system. So here, what FC protocol does is that it encapsulates the SCSI commands and transmits that between two FC nodes. What are FC nodes? Any two systems, if they are connected with fiber channel, that means fiber optic, then those two systems would be considered as FC nodes. So what FC protocol does here? It's a protocol used for SANs. It encapsulates the SCSI commands and transmits that between FC nodes. And we can also use a fiber channel switch to connect multiple FC nodes. Suppose this is a fiber channel switch, then it will connect multiple FC nodes in your network. Fine. Then comes this protocol, fiber channel over Ethernet. Now here, guys, fiber channel over Ethernet, it is also a protocol used in SAN. It falls under the category of fiber channel. However, the medium here is different. Now, medium may be this medium can be Ethernet medium, guys. That means it is Ethernet cable. That means or normal Ethernet cable. Okay. However, my SAN here is FC. Okay. And now ESXi issues SCSI commands, but I don't have a fiber channel cable here, fiber optic cable, but I have Ethernet cable. But I want to communicate with my fiber channel SAN. Then what is the protocol I have to use? FCOE. Now what FCOE does here? First, ESXi issues SCSI commands. Those SCSI commands are encapsulated into FC by the FC protocol. Then that FC traffic is encapsulated into FCOE frames, fiber channel over Ethernet frames, and these FCOE frames are conversed with networking traffic. So this is the reason why FCOE is used fiber channel over Ethernet. However, this switch which you are seeing in between, that would be an FCOE switch. That means this switch can handle fiber channel, okay, as well as your Ethernet. Okay, maybe this is an Ethernet network or local LAN. So FCOE switch on one way, it may be connected to your FCSAN. On the other way, it can be connected to your local LAN. Why? Because FCOE switch can handle FC protocol and FC traffic, as well as it can handle your Ethernet traffic. So in between you have FCOE switch. So fiber channel over Ethernet, it is also a protocol used in SAN, which will encapsulate FC traffic into FCOE frames. Then FCOE frames are converged with networking traffic. Now let us talk about iSCSI. Now iSCSI, I stands for Internet SCSI here. Internet, guys, Internet functions on which protocol? TCP/IP protocol. That means normal Ethernet connection can be used for it. It is also a SCSI transport protocol. Now this SCSI transport protocol provides access to the storage devices over TCP/IP network. Suppose this storage system is not an FC storage system, it is an iSCSI storage system. What would be the connectivity here? Obviously, Ethernet connectivity, okay? And if it is iSCSI SAN, then the SCSI protocol provides access to the storage devices over the normal TCP/IP network. And this is normal TCP/IP network. That means your Ethernet network. And here we use our normal physical switch. And here you have iSCSI SAN. Alright. So this is your iSCSI protocol. SCSI protocol provides access to storage devices over TCP/IP network. Then comes NAS. What does NAS do? It provides access to the storage shared. It provides access to the storage shared using a protocol, or we call it as a file system. NFS stands for Network File System over TCP/IP network. It uses NFS protocol. Fine. In NAS, guys, we are not accessing blocks, but we are accessing folders basically. Alright. No doubt these protocols are termed as NFS Network File System, CIFS, SMB. They are called as file systems, but basically these are protocols. For example, NFS, the name is Network File System, but this is not the file system similar to the file systems of operating systems where we can format the hard disk. No. This is a protocol used in NAS devices in order to export these folders as local folders to your network. Fine. So NFS is nothing but a protocol. Alright. Now, VMFS, guys. VMFS, Virtual Machine File System. Now this is the file system of your ESX or ESXi, and using this file system will format the hard disk. So where you get hard disk? So VMFS can be only deployed on SCSI based storages. Either the directly attached storage, that means direct attached storage, direct attached hard disk can be formatted with VMFS, or you find LUNs on your FC fiber channel LUN, or it can be an iSCSI LUN can be formatted with VMFS. And here, ESXi supports NFS version 3 over TCP/IP. And if you remember, guys, I was discussing about the files associated with virtual machines. Okay, and there I mentioned that if you are storing your virtual machine on NAS, there might be an extra log file. That is this log file, guys. Now it is here. If you are storing certain data, that means your virtual machine on NAS, it uses a different blocking file. That block file is .lck-field ID. Alright, this is an overall idea about SAN and NAS and different protocols being used in our technologies, in our IT infrastructures. Now before I move forward discussing in detail about iSCSI SAN storage system, guys, any doubts, any questions on this? Guys, any questions, please do raise and clear it off.
You mentioned, Mujib, about
yes.
the folders in NAS,
yes.
using different protocols.
Yep.
The NFS and CIFS and SMB.
Yes.
You also mentioned that ESX would reject a communication or something. I missed the part. And you mentioned you could format it with a different.
No. So here ESXi can access only those folders on NAS which have been exported using NFS protocol. So ESXi supports only NFS protocol. It doesn't support CIFS and SMB. So if you export a folder using CIFS, then ESXi will not be able to access that folder. Why? Because it doesn't support that particular protocol. ESXi supports only NFS protocol on NAS. Yeah?
Okay. But how does it work if in case, there's introducing a CIFS and SMB?
The CIFS and SMB are protocols supported by some other operating systems, okay? Like, for example, CIFS supported by Windows. Windows supports CIFS, okay? And the other operating system supports CIFS, but ESXi doesn't support CIFS, okay? It supports only NFS protocol. So if you want to use NAS with ESXi, then you have to make sure that you are exporting that particular folder or sharing that particular folder with the NFS protocol. Clear? Clear, guys? It is all about the support. ESXi supports only NFS protocol. It doesn't support CIFS and SMB. Alright? Any other questions? Apart from this? Any other questions, guys? Any other questions? Can I move forward? Can I move ahead, guys? Yeah. Now let us try to understand in detail about iSCSI SAN storage system and how this technology functions, what are the terminologies, so on and so forth. Now, guys, iSCSI SAN storage components. The iSCSI storage system, as I inform you, it contains multiple hard disk drives, and you have RAIDs configured in the background. Okay, and using those RAID sets, I create LUNs. Okay, and there is something called storage processors available on your iSCSI SAN storage system. And iSCSI, I stands for Internet SCSI. This is a protocol which gets transmitted over our TCP/IP network. So the network is normal Ethernet network here, and we have servers who accesses this iSCSI SAN storage system and try to access those LUNs. Now let me discuss this iSCSI SAN storage in detail. Okay. Let us assume that this is my iSCSI storage system, and here it may contain multiple hard disk drives, and in the background we may be using RAID sets, right? And that can be software or hardware level RAIDs, and using these RAIDs we'll create RAID sets. These hard disks are connected in the background, let us say. And I create certain RAID sets. Using those RAID sets, I create LUNs. You can create multiple LUNs of multiple sizes. Okay. And there is something called storage processors available on our storage iSCSI SAN storage system. Nothing but my LUN. And these are my storage processors. Okay, and the network is normal TCP/IP network, and here I have my servers or hosts, and my servers and host access these LUNs in my network. And in between we have TCP/IP network. Maybe I have physical switches or Ethernet switches, multiple Ethernet switches, and the connections from my servers. This is my TCP/IP network. Fine. Now, this is my. Let us try to understand the terminologies and the components and what they do basically. Fine. So this entire thing is my iSCSI SAN storage system, and I can call it as my iSCSI SAN server. And what is there on my iSCSI SAN server? Multiple hard disks. In the background, RAIDs configured. You can create RAID sets. Using those RAID sets, I'll create multiple LUNs. Alright? These are my LUNs which have been created using those RAID sets. Then, there is something called targets on my iSCSI SAN server. Targets. Now, what do targets do? Target presents LUNs to our servers in our network. Target presents LUNs to our servers. There is something called targets. Okay, the target may have a single LUN attached to it, or it may have multiple LUNs attached to it. So targets present LUNs to our servers on our in our network. And there is something called storage process. I'll talk about storage process in detail as I move forward. Fine. And I have TCP/IP network because it is an iSCSI SAN, Internet SCSI, so SCSI protocol transmit over normal TCP/IP network. And I have hosts connected to my network. Alright. Now, my host has to access the LUNs on my iSCSI SAN server. Fine. Now, normally my host cannot access the LUNs or the targets, if I say, on my iSCSI SAN server. Okay. Normally, I require something on my host. What is that? I require iSCSI initiators. I require what? iSCSI initiators. So on my host, I need to have iSCSI initiators. I need to have iSCSI initiators on my host, on my system, so that these iSCSI initiators can initiate a connection to the targets, so that my system can access LUNs on iSCSI SAN. So there are two types of iSCSI initiators used on our servers, on our hosts. The first one is called as hardware iSCSI initiator. The first one is hardware iSCSI initiator. Hardware iSCSI initiator is nothing but a special kind of iSCSI card. As we have our NIC cards, in the same way we have a special kind of an iSCSI card. It's a hardware device, okay? And that hardware device is required on your ESXi host in order to initiate a connection and try to access the targets on my iSCSI SAN server so that we can access LUNs. So you require iSCSI initiators on our servers. The first type of iSCSI initiator is called as hardware iSCSI initiator. It is nothing but a special kind of an iSCSI card. Sometimes we also call them as iSCSI HBAs. HBA stands for Host Bus Adapter. Now, for example, what is the network here? TCP/IP network. Now, if you don't have a hardware iSCSI initiator, that means a special kind of an iSCSI card which can handle SCSI protocol and which can initiate a connection to your targets on your iSCSI SAN server. You can also use your normal NIC card which is available on your host or on your servers, but your normal NIC card cannot initiate a connection to an iSCSI target. Okay, it doesn't have that functionality. Okay, so what is required? If you want to use a normal NIC card, you can also use it, but it also requires something else. The second kind of initiator, which is called as software iSCSI initiator. Now, what is the software iSCSI initiator? It is nothing but software iSCSI service. Okay. Now, who provides this software iSCSI service or software iSCSI initiator service? It is provided by the operating system. The operating systems will have the software iSCSI initiator services. For example, on my server, I am running Windows. So Windows will have Microsoft software iSCSI initiator service. If it is Linux, Linux has software iSCSI initiator service. In our case, what is the operating system? Our operating system is ESXi. So here, ESXi provides that software iSCSI initiator service, and that appears as on ESXi software iSCSI adapter. Okay, so here on the servers, on an iSCSI SAN server, we have hard disk drives, in the background certain RAID sets for redundancy. Rates we configure for redundancy, and we create RAID sets. Using those RAID sets, I create LUNs, I have storage processors, and there is something called targets available on our iSCSI SAN server. These target present LUNs for host in our network. Now, what is required on our host in order to access those targets and LUNs? We require iSCSI initiators on our ESXi host. iSCSI initiators are of two types. The first one is hardware iSCSI initiator, that is nothing but an iSCSI card, special kind of an iSCSI card, or you can call it as iSCSI HBA, which has the functionality which can access your iSCSI SAN target, and the LUNs would be presented to your server. If you don't have an iSCSI hardware iSCSI initiator, you can also use the normal NIC card, but normal NIC card doesn't have the functionality to initiate a connection to your iSCSI SAN server. For that, you require software iSCSI initiator service. Okay, and the software iSCSI initiator service is provided by the respective operating system running on it. In our case, it is ESXi. So ESXi provides software iSCSI adapter. Using the software iSCSI adapter, if you don't have an iSCSI hardware iSCSI adapter, not a problem. Your NIC card, along with software iSCSI initiator, can initiate a connection to your iSCSI SAN server, and you'll be able to access the targets. Here, guys, you get the concepts and the terminologies and what are the components which are required. Any questions?
Could you explain targets again, please?
Guys, on iSCSI SAN server, we call, in other ways, we have targets. Okay. Now these targets present LUNs to the system, or in other way you can call a LUN as a target. But basically, we use the terminology called target. We create targets. Initiators will initiate a connection to a target, and that target will have one LUN or multiple LUNs attached to it. So normally targets present LUNs to the initiators. Yeah?
Okay.
Fine? Fine? So, yeah. So this is the overall, terminology, components, and the components required on your iSCSI SAN network. Fine. Now here, guys, as I told you that iSCSI SAN or SAN is normally a centralized storage or it is a shared storage, and it may contain multiple hard disk drives, lot of data, lot of space is available on it, and we create multiple LUNs, and these LUNs can be used by multiple departments in your infrastructure. Suppose we have a Windows department, we have Linux people, we have Exchange people, we have database people, we have SAP department, we have virtualization like ESXi. There are so many people, and we all use these SAN LUNs to store our data. And suppose there is a database department, there is an Exchange department, and there is a VMware department. Let us say Exchange department has requested the storage administrator to assign a storage space of 10 terabyte. So what storage administrator is going to do is that he is going to create a LUN of 10 terabyte. Again, let us say database department has also requested the storage administrator to provide a space of around 10 terabyte. Okay, and then VMware department or virtualization department has also requested the storage administrator to create a space or provide a space of 10 terabyte. Now, all the three departments have requested to create a space or provide a space of 10 terabyte. Now, getting these requests, let us say the storage administrators has created 3 LUNs of each 10 terabyte each. Okay. Now, in my infrastructure, I have Exchange people, okay, database people, and we virtualization people. Now, we all are trying to access those LUNs. And when we try to access those LUNs, okay, let us assume that all those 3 LUNs are exposed to me. Okay, let us assume those 3 LUNs are exposed, okay, for my ESXi department. In the same way, those 3 LUNs are exposed to, the Exchange department, and in the same way, those 3 LUNs are exposed to the database department. Now, what is going to happen? What is going to happen is that, now let us assume the first LUN, second LUN, and the third LUN, all the 3 sizes are equal. Let us say first Exchange department thinks that, okay, this LUN of 10 terabyte is for me, and they'll format that with NTFS, and they are storing certain mailboxes on it. Okay. Then database department has requested for 10 terabyte space. They also see these LUNs, but they'll select the first LUN. Why? Because they think that, okay, this is for us. And when they try to, obviously, let us say that database is running on Linux. So when they access that LUN, this LUN is represented as local LUN to the operating system. And then what happens? They'll format this with ext3. So what is going to happen is, in the background, this LUN was already being used by Exchange department. They have formatted that with NTFS and stored certain data on it. But unknowingly, my database department has formatted that particular LUN with ext3. In the background, the data is gone. Now after that, let us say ESXi department, that means our virtualization department, they also requested for 10 terabyte, and they'll think that, okay, this is for us. And again, they'll format that with VMFS. So, as these LUNs are on one box and these LUNs are exposed to multiple people, if they are exposed to multiple departments, then there is no security. Am I right? We don't know which particular LUN is being assigned to which particular department or who has to access that particular LUN. Are you able to understand, guys? Okay. So these kind of problems will come. So that's the reason why you need to have some sort of security to these LUNs. So we need to configure something where these are the LUNs and these are the targets which has to be accessed by so and so systems. So here, guys, how can we identify and how can we say that this is the LUN which has to be exposed to so and so system or so and so server? So that is identified in 2 ways. Guys, here I have something called targets. First, I need to identify targets. Then, who is accessing the targets? The initiators. That is the initiators. So, I need to identify the targets, I need to identify the initiators, then I can configure, okay, this is the target and this target has to be accessed by so and so initiator. Guys, how do we identify systems in our network? What are the identifications we use to identify systems in our network? IP address, absolutely. IP address can be used, host names can be used, right? So in the same way, here, targets can be identified with IP addresses, host names, okay? In the same way, initiators can also be identified with IP addresses and host names. So, identifiers in iSCSI SAN, it can be IP addresses, it can be host names, and we have a special naming convention in iSCSI SAN, which is called as IQN. IQN stands for iSCSI Qualified Name. Okay, fine. So here targets are identified by IP addresses, host names, or IQN names. Here this is a special naming convention used in our iSCSI SAN servers, which is called as IQN, iSCSI Qualified Name. Target will have an iSCSI Qualified Name. In the same way, initiators will have an iSCSI Qualified Name. So IQN, IP address, there is a naming convention. There is a naming, how we write an IP address, it's reprinted in dot and decimal format. Host name, we have the naming convention, how we write it. There is a naming format. The fully qualified domain name first, the host name, then followed by the domain name. In the same way, IQN also has a format. Now, that name starts in this way. IQN dot year, month, then reverse of the domain name. Suppose my domain name is zoom.com, then what would be the reverse of it? .com.zoom, followed by the alias.
Sorry, Majid, could you explain this box again, please?
Yeah, I'm coming there. I'm coming. Okay, fine. Now, guys, as I told you that if I don't configure access control, if I don't have some sort of security to my LUNs, to my targets, then multiple systems can access those LUNs, and unfortunately, knowingly or unknowingly, my data can be damaged. But because there should be some sort of security that this is the LUN or this is the target which has to be accessed or which has to be assigned only to these particular systems. In order to achieve that, there is something we can configure access control and how to identify the targets and how to identify initiators. I can identify targets and initiators with IP addresses. I can identify targets and initiators with host names, and I can also identify targets and initiators with an IQN name. IQN stands for iSCSI qualified name. Now, guys, there is a naming format. IP address is reprinted in a dotted decimal format, like, for example, 192.168.0.1. This is the naming format of IP addresses. In the same way, host name, how host name is identified. For example, ESXi1.zoom.com. So this is the host name. So this is the way how we write the host name. In the same way, we have IQN, iSCSI qualified name. It has a format. It is reprinted in this way. It starts with IQN dot year-month dot reverse of the domain name. For example, my domain name is zoom.com. What will be the reverse of it? .com.zoom, colon, followed by iSCSI alias. iSCSI alias is nothing but any friendly name or an alternate name given to the target or the initiator. Okay, clear? So this is how we can identify a target and an initiator. Now, what a SAN administrator does in order to give that security to those LUNs is that there are two ways how we can have access control. In our iSCSI SAN. The first way is we call it as access rights. Access rights. Now, in access rights, on the targets, I'll mention which are the initiators who can access this particular target. Clear? The first one in access control I can configure is access rights. In access rights, I'll select the target, and on the target, I'll mention that these are the initiators who can access this particular target. When I mention those initiators, then the connection from those initiators will be given to only to that particular target. Okay? So in this way, I can control access. The second method used in access control of iSCSI SAN server is CHAP authentication, or we use CHAP protocol. CHAP is a challenge handshake authentication protocol, which is used in our IT infrastructures. Okay? So I create a CHAP authentication key on my target, and I can share this key with the initiators. That means to the servers. So whenever you try to access a target, it will ask for a key, and when you enter the right key, then the access to that particular LUN is given. So on the targets, I create CHAP keys. Alright, and these CHAP keys are shared with only those departments which has to access those particular targets. And when they enter the right key, then the connection is connected. Okay, if not, the connection or the access is denied. Okay, guys, this is how we control access in iSCSI SAN by access rights and CHAP authentication. Okay, guys, any doubts with this?
Majid, this is
any doubts with that? Yes. What is?
Sorry, I was
Yes,
saying,
actually.
what's access right? Can you explain that again, please?
See, in access rights, what I'm doing, I'm trying to control the access. I'm trying to provide security to my LUNs. If one LUN has to be exposed to only VMware department, then I should have some sort of security in place. That is what is called as access control. That I can achieve it in two ways. The first one is access rights. In access rights, what I do is that on the target, I mention the initiator's name. That these are the initiators who can connect to this particular target. Clear? And how initiators can be identified? By an IP address, by the host name, or by an IQN name. Fine? So on the targets, I mentioned that these are the initiators who can access this particular target. Once I mention that, then only those initiators will be given access. The other initiators will not be given access to that particular target. In that way, I'm controlling the access. Clear? And the second method is CHAP. I can use Shared Handshake Authentication Protocol. I can generate a CHAP key, and this key is shared with the specific department or specific people. And when they try to access a target, it will ask for a CHAP key, and when you enter the right key, then only the access is granted. If not, it is denied. Yeah. So this is how iSCSI SAN functions, and these are the terminologies, the components, all put together form your iSCSI SAN server. All right.
Mujib, this is Satyam.
Now let us. Yes, Satyam.
This is not our headache, right? That's storage. We just give a request to storage to give a LAN. He'll provide a LAN. That's it, right? It's not all our job, right?
Okay, fine. What you said is absolutely right. Normally, the creation of a LAN and the access rights and CHAP authentication, all this is done by the storage administrator.
Yeah.
Okay, so let me draw a line here. So that
We
you
do
understand.
only just give to the host, like we get to ESF and we give to the request server. That's it.
This line is red. It is here, right? This part is done by the storage administrator. This part is done by you. Okay? Fine. However, you as a VMware administrator, you should be aware of the terminologies. You should be aware how iSCSI SAN server functions. What is the meaning of access right? What is CHAP? What is an iSCSI initiator? What is an iSCSI target? Okay, what is an IQN name? iSCSI qualified name, so on and so forth. If you don't understand these terminologies and if you don't understand how iSCSI SAN server functions, then when you go out and work in real time, many times you need to interact with your iSCSI SAN server or your storage administrator, and he'll use a term which you don't know. For example, he say that give me your IQN name, give me IQN, share the IQN of your of your ESXi. Then what are you going to do?
IQN
Right.
is something
So this
like
knowledge is
IQN is something
this
like
knowledge
that.
is required.
No, I'm saying is, yeah, what you said is right, but IQN is something like that. It's a LAN ID, right? It's not a name like when you use a SCSI technology, you get a IQN number for your LAN ID. If you use FC adapter, you will get a just normal number, 16-digit, 32-digit number. If you use iSCSI technology in storage, you get IQN. Starting now, you will be IQN, and the remaining numbers will be for your LAN ID. And if you use FC storage, then you get just 32-bit digit number. That's it. That is what IQN I know, up to my knowledge.
See, as I told you, IQN is not only the ID for your LAN. Okay, you try to understand. IQN is for the initiator. IQN is also for the target. Keep that in mind. Okay, fine. There might be certain SAN servers which do not accept IP addresses and host names. They require IQN in order to provide access control. Fine. Alright, so here the storage administrator may ask an IQN for your iSCSI initiator. So you need to provide that IQN, which is generated. Fine. Or it may be a WWN. Then comes the fiber channel. I'm going to explain that in detail. However, you need to understand all these terminologies and what is what, so on and so forth, but it is required for you when you go out and work in real time. You need to understand these terminologies. Yes, Satya, you may know it, but there might be some other guys who don't know
I'm
about this
saying
technology.
I'm asking like real time, like we
someone
don't
new.
know.
Yes, for them there is new technology for them, new terminology for them. They don't know iSCSI SAN targets, LUN, storage processors, what is this iSCSI initiator and all. So I have to discuss. Who is this? Prabhakar?
Usman, I didn't know.
Usman, fine. So I have to discuss all these things. Absolutely essential. Alright? However, though this is not our job as a VMware administrator to create LUNs, to create targets, to create access control, so on and so forth. This is done by storage administrator. However, on your ESXi, you need to configure your ESXi so that it can access that particular iSCSI SAN target, and you need to access that LUN, format that LUN with EMFS, and store your virtual machine. So this end you are doing practically, but this part is done by your storage administrator, no doubt. What Satya said is right. This is not our headache, but it is the headache of the storage administrator. But however, we need to understand the technology, the terminology, so that we can work easily on without any confusion. Fine. Let us move forward from here. We'll try to understand iSCSI initiator. Now, what iSCSI initiator does, it transmits the SCSI commands over TCP/IP network, and the iSCSI target receives the SCSI commands over TCP/IP network. Now, here target presents LUNs to initiators. I have discussed already. Now, iSCSI addressing can be based on IP, host name, IQN name, as well as some SAN servers also accept MAC addresses. So IQN, it can have 255 characters. As I have mentioned there, it starts with IQN, year, month, reverse of the domain name followed by iSCSI alias. I have given the examples in this way. And sometimes a separate identifier is also used on our iSCSI SAN servers, which is called as EUI or Extended Unique Identifier. It is a 16-character number, alright, and it starts with EUI dot with the 16 characters, alright, and target will have an EUI as well as initiators will have an EUI. Now basically this is a 64-bit address. It is similar to your, as there is a MAC address, 48-bit MAC address. In MAC address, the first three octets are representing the company ID. The remaining 3 octets are representing the unique ID assigned to that particular NIC card. In the same way here, in EUI, it is a 64-bit address. The first 24 bits are the company name assigned by IEEE, and the remaining 40 bits are for the UID, unique identifier, extended unique identifier. Okay, so this is about your iSCSI SAN storage system. Fine. Okay, let us move forward from here, and we'll try to understand the types of iSCSI initiators. Guys, I already discussed that we have hardware and software iSCSI initiators. However, in hardware, again, there are 2 types. One is dependent hardware iSCSI initiator and independent hardware iSCSI initiator. Independent hardware iSCSI initiators are nothing but the special kind of iSCSI HBAs or iSCSI cards. Now, dependent hardware iSCSI initiators are certain NAC cards which have the functionality which can handle SCSI protocol, but they also depend on the operating system's functionality. However, in real time, either you go with software iSCSI initiator or an independent hardware iSCSI initiator. Fine. Now, as already discussed, that security on iSCSI is what we call it as access controls that can be configured using access rights. The second one is CHAP authentication as well. Now, here ESXi supports iSCSI multi-pathing. What is the meaning of multi-pathing here? That means more than one path. If you have seen this particular figure or this particular diagram which I have drawn, for everything there are 2 paths. I have 2 HBAs or iSCSI cards or NIC cards. Now, one is connected to one switch, the other one is connected to another switch. So this is multi-pathing, and ESXi supports iSCSI multi-pathing. Alright? And suppose you are using hardware iSCSI initiators, then there is nothing you have to do on your ESXi for multi-pathing. But suppose you are using software iSCSI adapters or software iSCSI initiators, then you have to do port binding. You have to configure port binding for iSCSI multi-pathing. You need not worry, I'll show you how to do that, how to configure that port binding if you're using iSCSI, software iSCSI adapter. Alright? So this was all about your iSCSI SAN storage system. Fine. Now then comes NAS or NFS. As we already discussed that NFS server, the NAS device that may have multiple hard disks, which is already formatted with some sort of operating system, file system, and we create folders on it. and we can access those folders from our ESXi host using the normal TCP/IP network. And here, ESXi host accesses NFS server using the IP address or the host name. Now, one thing is important here. Suppose you're trying to access an NFS folder from ESXi host. Now, normally, the storage administrators, whenever they create a folder on NAS box, and when they are trying to export that using NFS protocol, when you're creating that folder and you're exporting that folder to your network, when you're sharing that folder, there's an option where you can grant root access to that particular folder, or you can deny root access to that particular folder. Now, normally, storage administrators do not give root access to that particular folder whenever they are exporting this folder using NFS. Now, my ESXi will not be able to access the folders which has been exported with no root access. So what you have to inform your storage administrator is that he has to configure that NFS folder with no root squash option. That means he has to export that NFS volume with no root squash option. What is no root squash? No root means no root access. No root squash means granting root access. So you need to inform storage administrator to configure and export that NFS volume with root access. That means no root squash option. Okay, and ESXi also supports NFS multipathing, and that means you can have two types of connections, two NSE cards, and those two NSE cards, two different ways can access that NFS server. So ESXi supports NFS multipathing. Now, any doubts or questions on NFS here? Anybody confused with this no root squash option?
That's fine, but if you are using a NAS storage, so if you have multiple VMs, so how do we install OS on that VM? Like if you are using NAS?
It is the same thing.
Yeah, it's a like you are saying, like it's a folder, right? You can't format with some other technology. Yeah,
no doubt it is a folder. No doubt it is a folder.
So if it is a
but what I need to say is that when on SAN you access LUN and you need to format that LUN with VMFS. Okay. In NAS we are just accessing a folder.
Yeah.
Alright. And that folder is mounted as a data store for ESXi, and I can store this virtual machine. What is a virtual machine, guys? Nothing but a set of files stored in a folder. Folders getting stored on data store. ESXi has VMFS data store, also supports NFS data store. So if it is NFS data store, it is nothing but a folder on your NAS box. Okay. So you can store your virtual machine on a folder on the NAS box. Okay?
Okay.
Not an issue.
We can format with ext3, right? Then?
No, we are not formatting. We are not formatting the folder with VMFS anymore. Why? Because here it is not a block. It is a folder.
Yeah, that's why. How can
so
we install
ESXi can access that folder, but I can store the virtual machines folder on NAS.
Okay.
Okay, I can store the virtual machines folder on NAS box. That means on NAS folder. Can't I store a folder on inside a folder?
Yeah, you can store, but the format thing
it is the same way.
I'm asking.
But no formatting here. Why? Because it is not a hard disk to format. I can't format a folder.
Okay.
Alright?
Yeah.
So I'm storing a folder inside a folder. Just try to understand this. Why? Because I'm not accessing a block. I'm accessing a folder which has been shared. And when ESXi accesses that folder, it is considered as NFS data store. And whenever I'm creating a virtual machine, I can also store my virtual machines on NAS box. Not an issue. Okay?
Usually, which one we use, like NAS or SAN for VMware?
Guys, in real time, 99.99% we use SAN when compared to NAS. Why NAS is used normally in very big infrastructures? To store ISO files of our virtual machine. We can mount ISO files of our virtual machine, and so that during the installation I can use those ISO files and do the installation inside our virtual machine. Okay?
The small companies, like not big companies, the small companies, like
Even small companies use SAN, okay, some sort of cheaper SAN. They don't go with enterprise class SAN boxes. They can go with open source as well. There's an open source software based SAN which is called as OpenPiler. Okay, you can configure OpenPiler on a machine and create LUNs, and you can store virtual machines. Even you can run production virtual machines in OpenPiler. Okay, and some companies also go with some sort of software called Starwind. I can also store my virtual machines on iSCSI SAN server, like Server 2012 has this functionality where you can store, you can create an iSCSI SAN server, and you can store virtual machines on it as well. So it depends on the infrastructure. Fine.
Yeah, because I'm asking this because we have like demand on like VMware with NAS. So that's why I'm asking you, like, better to go for NAS or SAN? I want your suggestion on that. Like, I have demand in NAS and VMware. Like, because the market is very low market, we don't have the big market. We don't have the like MNCs here. We have only small industries. So I think that they prefer for VMware and NAS. Like, as of now, I see in the websites they're asking for VMware and NAS. So that's why I want to know, like, exactly, should I go for NAS or SAN?
See, according to me, go with SAN, because once you understand the SAN technology, NAS is not that difficult to manage. So you can manage even NAS without any issues. The only difference here is that protocols, okay, nowadays, that's the reason why previously there were different machines for different storage technology. For example, a separate machine which used to handle FC, fiber channel SAN, a separate machine for iSCSI, and for NAS boxes, a separate box. Now, what the original equipment manufacturers of storage, like EMC Square, NetApp, IBM, Hitachi, HP, what are they developing? They are coming up with unified storages. What is the meaning of unified storage? One box, okay, and it can handle all the protocols of SAN like FC, iSCSI, FCOE, and it can also act as NAS box. It can handle NFS, EFS, SMB, or any other protocol used in NAS. So they are coming up with unified storages. The single box can act as SAN as well as NAS box. It can handle all the protocols of SAN. It can handle all the protocols of NAS. So that's the reason why I'm suggesting you to go with SAN rather than only going with NAS. Alright?
Yeah, thanks.
So if you want to take up a course, go and take up a course which includes or which is going to teach you unified storage. Something like it contains everything. It contains SAN on it, it contains NAS on it. It can act as SAN, NAS, it can act as fiber channel SAN, it can act as iSCSI SAN, it can act as FCOE SAN, it can act as NFS, and VCS. Okay?
Thanks, man.
Right, you're welcome. So better to go with that kind of unified. Nowadays, even smaller organizations are moving towards unified storages. But the advantage is that one box can act as multiple solutions. So it can handle all the protocols. Right. Let us move forward. Now here, we'll try to understand FC SAN. Here guys, the only difference here would be that the terminology and the protocols. Here, it is not called as an iSCSI SAN server. Okay, it is called as a FC SAN. Okay, I call it as FC SAN system or FC. Okay, I have multiple hard disk drives on it, and then in the background I have RAID. I create RAID sets. Using those RAID sets, I create LUNs. Now there is no term in FC SAN like targets. We don't call them as targets. Okay, so there is no concept of targets here. Alright? No. I don't have these as well. Targets and initiators. Nothing. I don't have initiators here as well. No requirement of initiators. It is not TCP/IP network. Why? Because it is fiber channel. There is no concept of access rights and chat. Though we have access control, but we configure it differently. Alright? So here, the network is fiber channel, FC, and these are FC switches. Alright? I have FC sandbox, LANs created, I have storage processors, and the network is FC, fiber channel switch. And here on my servers, on my host, I require FC HBAs. So this is normally HBA is the term used in only fiber channel. HBA, host bus adapters. So I need to have host bus adapters on my ESXi servers on my host, and from there fiber optic is getting connected to my fiber channel switch. From my fiber channel switch to my my FC SAN server. Alright. So the terminology is here. We don't have target terminology and initiator terminology. Alright. We have FC switches, ESXi host with HBS. Alright. Now, here also we create LANs, and these LANs may be accessed by multiple systems in our network. Now, I need to go with access control here. In order to have access control, I need to identify the host, and I need to identify the FC SAN, and how. What is the naming convention? How we are going to identify that? There we had the concept of IQN, iSCSI qualified name. But here we have the concept of WWN. WWN, worldwide name. Now this WWN is a worldwide name. It's a unique name given available on our FC nodes. What are FC nodes? Any two systems which are connected with fiber optic or fiber channel, that's called an FC node. Here FC SAN is also an FC node. My ESXi host is also an FC node because they are connected using fiber optic or fiber channel. Fine. So we have WWN, worldwide name. Now it is nothing but the address of your HBA, host bus adapter. Fine. So here on the server, I have HBA. HBA has this WWN, worldwide name. Okay. In the same way, the FC SAN node also has a WWN, worldwide name. Fine. And here, access control, okay, is done by two methods. The first one, let me write it here, on our FC SAN. It is done by LUN masking. The first method is LUN masking. Okay, what is mask, guys? What is a mask, and why do we use a mask? Mask is to hide ourselves, right? Alright. So here, LUN masking. Now this is configured on the SAN, system. Here what I do is that I'll select a LUN and I'll mask it. Okay. That means I'll hide that particular LUN from certain servers. And when I hide that LUN from certain servers, automatically this LUN is exposed to other servers. So this is LUN masking. This is the first method by which I can control access. The second method is called as zones or zoning. Now this is configured at FC switch. This is configured on the fiber channel switch. This is configured at FC switch. So let me compare this. It is not exactly the same, but just for your understanding, guys, on my physical switch, for segregation of traffic, I configure VLAN, right? You understand that? I configure VLAN for segregation of traffic. In the same way, here in fiber channel SAN, in order to segregate the traffic, so that the right LUN is exposed to the right servers, okay, to the right HBA, we configure zones on fiber channel switch. So zones configured on the fiber channel switch will decide which particular HBA. Now HBA has WWN, right? With the WWN, using the WWN, I can configure zones. So zones configured on the fiber channel switch will decide which particular HBA is going to access which particular storage processor and which particular LUN. So here, if I configure zones on FC switch, then FC switch is going to segregate the traffic and is going to provide access to the storage processors as well as to that specific LUN. So here we use LUN masking. LUN masking is configured on the SAN, on the fiber channel SAN, where we hide certain LUNs with the other HBAs and we hide certain LUNs with the other HBAs. That means the other servers. So zones is configured on the fiber channel switch. Apart from this, the technology or the LUNs, what we call it as the storage processors, absolutely the same. We don't have the terminology like targets and initiators here. Now here the FC SAN or the LUNs are identified by your WWN worldwide name. Okay, using those worldwide names, I configure LUN masking and zoning. Right. So let us try to understand furthermore what is FC SAN here. Now here guys, what is a LUN? Try to understand what is a LUN. LUN is nothing but a logical unit, and it is the address of a logical unit. Okay. Now, logical unit. What is logical unit? Is nothing but a unit of storage where we can store data. Now, that logical unit can be a JBOD. JBOD is nothing but just a bunch of disks, guys. There may be certain servers using JBOD. In JBOD, there is no RAID, guys, in the background. Okay. So, the JBOD are just a bunch of disks which can be used to create LUNs, and they can also be RAID sets. So, RAID sets can be partitioned into multiple LUNs. So what is a storage processor? We have seen the storage processor on iSCSI SAN as well as on our fiber channel SAN. Storage processor is responsible for partitioning the JBOD or a RAID set into LUNs, and storage processor is also responsible for restricting the access to a particular LUN from servers. So on fiber channel SAN, I do that LUN masking, right? So LUN masking. Now which is the component which is restricting the access to a particular LUN from servers? That is the storage processor. Now, HBA. What is HBA? Host bus adapter, a special kind of card which connects your ESXi host to a FC network. Right? FC switch, fiber channel switch. Now, fiber channel switch is used to connect multiple FC nodes in your network. And guys, your FC network, if there is no fiber channel switch used, that means from end to end, from your server directly can be get connected to your FC SAN with no switch in between, then that network is not called as FC fabric. If at least one FC switch is used in your FC network, then it is termed as FC fabric. So that's what it says. FC switch forms the FC fabric, and it is used to interconnect multiple FC nodes. And what else FC switch does? It adds source and destination packets, source and destination addresses to the packets which are being forwarded by the FC switch. So it adds the source and destination addresses to the packets. Now this is how when you configure zones, it's going to segregate the traffic based on it. Alright, FC addressing. Now FC addressing is by WWN, unique 64-bit address, similar to your your EUI, extended unique identifier. However, it is reprinted in this way. Now this 64-bit address is assigned to FC nodes like this. Okay. Now, it is nothing but similar to the MAC address available on your NIC card. In the same way, this is the address available on your HBA, host bus adapter. Now, access control in fiber channel SAN, LUN masking. This is configured at storage processor, that means on the SAN. And zoning or zones, this is configured at the fiber channel switch. And zones configured on the fiber channel switch will decide which particular HBA is going to access which particular storage processor and which particular LUN. Now here guys, ESXi supports 16 Gbps fiber channel. Now guys, the speed or the bandwidth available on your fiber channel network depends on three things. Or let me tell you four things. Okay, basically. First one, your HBA. Guys, HBAs support from a bandwidth range of 2 Gbps till 16 Gbps. So if you have only a 2 Gbps HBA, then you cannot get 16 Gbps. So first one, it depends on HBA. Second, also it depends on FC switch. Your FC switch also needs to support 16 Gbps. FC switch fiber channel switches will support 8 or 16. Okay, FC switch. Third one, your storage system. That means your SAN server needs to also support. SAN server or your SAN needs to support. And the fourth one, your operating system needs to also support. In our case, it is ESXi. So if you want to get 16 Gbps connectivity, then these four components has to support the 16 Gbps. First, your HBA should have 16 Gbps. Fiber channel switch should support 16 Gbps. Your SAN server needs to support 16 Gbps, and ultimately the operating system running on your system, ESXi, needs to also support 16 Gbps. So here, ESXi supports 16 Gbps fiber channel, okay, and it also supports multi-pathing. And guys, LUN is nothing but logical unit number, that is the address of the logical unit. And there are LUN IDs like LUN 0, LUN 1, LUN 2, LUN 3, 4, 5, 6, that way. So VM kernel scans for those LUNs with the LUN IDs. Okay, and VM kernel can scan only the LUNs from 0 till 255. So it cannot scan a LUN with an ID 256. VM kernel can scan only LUNs with the ID 0 to 255. That means maximum LUNs which you can configure on your ESXi is 256, 0 till 255. That means totally 256 LUNs. Alright guys. So any questions on FC SAN guys? Any questions? Any doubts?
Address is assigned automatically or we have to assign manually?
The address you're talking about, guys, HBS comes with that WWN, okay? And sometimes your storage administrator may ask the WWN of your ESXi host. So when you give the WWN to him, he'll configure that on the FC switch. He can configure zoning, okay? He can configure zones. So once he configures the zone, see guys, the good part of FC is that on your ESXi host, normally there is no much configuration you have to do. You have your HBAs, and the HBAs, they are auto configured, and whenever there is something configured on your FC switch by your storage administrator, he has configured zones and LUN masking, whatever you have done. So the HBAs will directly get connected to your your FC SAN, and what are the LUNs which are given access to your HBA is going to access that. So auto configuration is done. One thing. However, you as a VMware administrator, suppose you get an opportunity to work in an implementation where you have to implement this FC SAN, that you have the server available and you are responsible for doing that installation on your ESXi host, that what type of HBA you want to connect and all. So my suggestion is that whenever you are configuring, you get an opportunity to configure most of the infrastructures. Already everything is configured. You just go there, manage it, and if there are any problems, you troubleshoot it. But sometimes you may get an opportunity to implement the infrastructure. At that time, one particular thing what you have to make sure is that you should not use the HBAs of two different manufacturers on the same host. Okay, for example, you're using two HBAs for multi-pathing. So don't use different manufacturer. Like maybe one HBA is from one manufacturer, the second HBA is from second manufacturer. Better to avoid it. Have the same manufacturer HBAs, and they may be of different model numbers, no problem with that, but make sure that you have the same manufacturer HBA on one particular host. Don't mix with multiple manufacturers. That is one thing you need to keep in mind. Any other questions apart from that? Any other questions? Any questions, guys, regarding FC SAN? Alright. Alright, guys, now let me discuss FCOE and I'll end the session. It's almost 6. On the close, can we continue? Can we discuss FCOE? Yeah, sure. We'll continue tomorrow then, guys.
These concepts are very dry, I suppose. It's very theory.
Yeah, these concepts are dry, no doubt. And online it will become more dry. It is classroom, there will be an interaction. And online it will become totally dry. I totally agree with that. So tomorrow we'll continue with these FCOE and storage device naming, and then we'll start the practical. I'll show you iSCSI plan configuration by use Server 2012. I'll also show you how to create a LUN tab, how to create a target, how to configure access rights by configuring iSCSI initiators. Then we'll also see what to be done on our ESXi host when the SAN is ready with the LUNs and all. Okay, so we'll see both the parts. The part is done by the storage administrator on an iSCSI SAN. We'll also see you as a VMware administrator what you have to do on your ESXi, so that you have an idea about iSCSI SAN. Fine. Alright, so we'll see both the things tomorrow, and we'll configure ESXi so that it can access an iSCSI SAN server. It can access that iSCSI LUN, how to format that LUN with VMFS, and we'll discuss more about VMFS. There are two versions of VMFS, VMFS 3 and VMFS 5, and we'll format that LUN with VMFS, and we are going to store our virtual machines so that we are ready for the next practicals like motions, migrations, vMotion, storage vMotion, and hack vMotion, so on and so forth. Alright guys? Alright guys, then we'll catch you tomorrow then.
Thank you, Mujib.
You're welcome. You're welcome. Yes, welcome.
సరిపోతుంది